So for our first physics labs, we talked about charge states, and it was rather a very simple but interesting experiment. The materials were a transparent tape, a ruler, a flat surface, and two thick books, and the goal was to study how tapes can have excess of charge and how they interact with themselves and other objects, such as our hands or pens, for example. Mainly the topics that this lab oversees are electric charge, electric field, Coulomb's law, electrons and protons, and others more, such as polarization. And I will go into further detail into each of these as I go further into the video. On the top left corner, you can see what was basically the main part of this experiment. There was a tape pasted into a flat surface, and then we would put a second tape, let's call it U tape, on top of it. And once we had it in top, we would fastly pull it away, and then this U tape would be charged with electrons. So the tape would become negatively charged. As you can see in the bottom picture, since the tape was negatively charged and we closed our hand into it, it would attract to the hand, basically because our hand is a neutral object and the tape is negatively charged. And by neutral object, it doesn't mean that it doesn't have any charge, but rather that it has the same amount of positive of protons and the same amount of electrons. Also, a good thing to talk about right now is polarization. And so when we move our hand close to the tape, the electrons in our skin are repelled and move away. So now the skin in our fingertips are positively charged, and since they are positively charged, they attract the tape that is negatively charged. And so that's how that attraction works. On the top right corner was the second part of the experiment, and this one talked about how if we had two tapes that were of the same charge, for example, if they were both negatively charged, then the tape B, as you can see, which is the red one, would actually go up a little bit because they would repel each other since they were both the same type of charge. As for the coding, here were my calculations. I first calculated the gravitational force by using the distance we got in the lab, and then I calculated the charge in tape B, which is actually the same one in tape A, and then I divided that result by the charge of an electron, and that would give us the number of total electrons in the tape. And as you can see, we got that the charge was actually a very small number, 1.42 times 10 to the negative 9. And to answer the questions that are the last two questions that are for the lab. So for the first one, if electrons had positive charge and protons had negative charge, for example, the behavior with our hand wouldn't actually change, because since our hand is neutral, and in this instance, if the tape is now positive, they will still attract each other because they are opposite charges. Well, not opposite, but they are not the same denomination. But for example, if now the tape is positive and we put it against a pen that is negatively charged, then these would attract each other, rather than repel each other if we had the tape with negative charge. And for the last question, it is important to handle charged tapes as little as possible, because a charged body loses its charge if we touch it with our hand, basically because a charged body loses its charge and becomes neutral due to the process of earthing. So since our body is a good conductor of electricity, it transfers the charges back to Earth, and thus the object that we're touching loses its charge. So essentially, if we want to avoid um, removing the charge of a positively or negatively charged object, we should touch it the least amount of time we can.